Now that we understand what a stack is, let's look at how we can build one. Now there's two ways that we could do it, either with an array or with a linked list. And we're going to use a linked list style in this example. So here I have an element class, and you see I have an integer value. Of course, it doesn't have to be an integer. This could just as easily be any other object that I want to store. I'm just using integers, so it's real easy to work with and gets the good concepts across. Notice that we have an element, we have values, and we have the ability to both get and set the next element. Inside of our stack is going to be pretty simple. In fact, it's a little bit easier than even working with a linked list. So inside my stack, I need to have my top element. Remember, as we add new items, it gets put on top and other elements get pushed down. So I'm going to have a private element top. And that's all I have to have. Now, I may add other things like a counter in there, but that's not required. Now I'm going to have a constructor. And I'm going to assume a constructor where I don't have any elements. I could also build a constructor where I get an initial element. That, however, is not necessary. Now, a stack typically has three methods that we need to use. A push, which adds elements onto our stack, a pop, which removes them, and a top, which lets us see what the top element is, but does not remove it. So let's build those real quickly. So here I have a push. We're going to add an element on. And in order to do this, I need to get a value passed in. So here's our value parameter. And I'm going to add a new element. Since we're going to push whatever is already on our stack down, the next element for E is going to be what's currently on our top. So E dot set next is going to equal this dot top. Remember, this is just a pointer reference. It is not the actual object. So we're just creating a new link to it. Then we're going to set this dot top equal to the element that we just created. And now whenever we need to use it, it's right there for us. Push is that easy. That's all we have to do. Now, let's look at pop. In this case, we're going to return a value, and we don't need to take any values. So this is pretty easy. What happens if our stack is empty? This is a question we always need to ask ourselves, because we might have a request to pop when we have nothing there. Well, there's a couple ways that we can handle this. First off, we could throw a stack empty exception. Now that would require us to create an exception, or maybe we could throw a element not found exception. Once again, require us to create an exception. We're not wanting to do that. We're going to just keep this simple, and we're going to return 0. The way we're going to do this is we're going to specify a new return value. And I'm just going to say int value equals 0. And then down at the bottom, I'm going to return value. Now, in between here's where we're going to check to see if our stack is actually empty or if we have a value that we can return. So what I'm going to do is I'm going to say if this dot top is not equal to null. That means I have a top element. That means I'm going to have a value to work with. Then I'm going to say value is going to equal this dot top dot get value. So now I've assigned it that value. We're assuming, of course, in this example that All of our values for our stack elements are positive integers. That's the reason why we use 0 is considered to not be found. Whether or not that would work in your case, that's a case-by-case scenario you have to kind of figure out. Now, the next thing we need to do is remember pop removes that very top element. So I'm going to say this dot top is now equal to this dot top dot get next. Now, what happens if our get next is null? Well, in that case, our this dot top is now going to be null and our stack is empty. But this removes that element from our stack. In a language like Java, it's actually going to mark that old object now for deletion for later garbage collection. If you're using another object-oriented language, Python, C#, they handle their own way. If you're using something like C++, then you'll need to go and delete that object, but otherwise we're not going to have to worry about it. Okay, so let's look at our top. Our top is almost identical to the pop. The only difference is the fact that we're not going to delete our node. So I'm going to come up here. I'm actually going to copy and paste this. But then I'm going to change the name from pop to top, and I'm going to remove the one line that deletes the node. So notice this is almost identical. In fact, we're one line less. Now, that is all we need to create a stack if we're using a linked list style. That's it. One class, less than 33 lines of code, and an element class that, if you look at it, is 21 lines of code. That is literally it. Let's build a real quick test app just so we can see this working. All right, so now that I have my main method, I'm going to create a stack object. Stack. And remember, the last elements we pass in is going to be the first elements we get out. So I'm going to say stack.push. Remember, I don't add, I always push, and I'm going to specify 10. Next, I'm going to call system.out.println, and I'm going to print my pop. So this is going to hopefully push in 10 and pop out 10. I'm going to do it a second time just to make sure we don't get any errors and we get that 0 that we're kind of expecting. So notice I'm kind of mixing up. I don't have to do a one-for-one. I can do several pushes and then a pop, or then maybe a push, then maybe 2 or 3 pops. This all depends upon how my program is running. In this case, I'm getting an example and I get to test this myself. Okay, so I'm going to run this. And you notice that I get the 10, which is the first item I pushed. Then I tried to pop something that wasn't there. Remember, we didn't set up an exception, so we just got a 0 back. I push a 6, and then I push a 3, which pushes a 6 down. Then I push a 9, which pushes it down further. Then a 16, and that's on top. And then when I pop, I get to 16, and then I get the 9. I push an 11, then I pop, I get the 11. And you can see how this is working just as we would have expected it to for a stack. And so our stack works as we expect, very simply, very easily, inside of a linked list style. Now, I'm also going to show you in the next video how to create a stack using an array. And that's going to be pretty simple too, but it's going to allow us to have to keep track of a few things. And we'll see what those are.